Multivariable differentiation. What we must know: when you have a function that is written in the form of y equals x squared plus 3x, and we differentiate that function, then we are performing an explicit differentiation. Notice that in this form, y is isolated from x. Then, when we differentiate a function that is written in the form of y equals x squared minus 2x times y to the third plus 4y plus 2, then we are performing an implicit differentiation. And notice that in this form, the y cannot be isolated from the x. So how do we do this? How do we perform an implicit differentiation? Before anything, we must understand that when performing an implicit differentiation, we will be differentiating all terms with respect to x. This means that when we differentiate terms that involve x alone and or any constants, then we follow the normal explicit differentiating rules. Then when we differentiate terms that involve y, we differentiate as we would differentiate an x term. The only difference is that we multiply our answer with dy over dx, since we are taking the derivative of y with respect to x. Lastly, we solve for dy over dx, and the implicit is done. Let's look at an example. Find the equation of the line that is tangent to the curve of 5 equals x squared plus 4xy plus y squared at the point 1, 2. The first thing that we're going to do is differentiate. Let's look at any x terms and or constants that are in this function. In this case, we have 5 and x squared. Once we differentiate them, we end up with 0 and 2x. And notice that we multiply dx over dx times the derivative because we are deriving x with respect to x. Now we differentiate terms that involve y. In this case, we have 4xy and y squared. Notice that when we differentiate 4xy, we're going to have to use the product rule. Once the product rule is used, we end up with 4y plus 4x times dy over dx. And in this case, we're multiplying the 4x times dy over dx because we are taking the derivative of y with respect to x. Then when we differentiate y squared, we use the same method. We differentiate as normal, so we get 2y and we multiply times dy over dx. Lastly, we put it all together and we solve for dy over dx, and we get negative 2x minus 4y divided by 4x plus 2y. Now that we're done differentiating, we evaluate dy over dx at the point 1, 2, and we get negative 10 over 8. So this means that the slope of our tangent line is negative 10 over 8. Number 2, getting the equation of the tangent line. Now that we have the slope of the tangent line and the given coordinate, we could use the point slope formula, input the data, evaluate it, and simplify it to end up with the equation of the tangent line. And in this case, we end up with y equals negative 10 over 8x plus 36 over 8.